Welcome to another exciting educational video brought to you by Upvision Concepts Academy. So we're looking at physics again, calculations based on equilibrium of forces. That is what we're looking on. So we're going to get questions from NECO, JAMB, and GCE WAEC that borders on equilibrium of forces. So this particular question on the board is JAMB 1998 question, and it says a uniform metal rule weighing 0.5 Newton is pivoted at 30 cm mark. Where should a 2 Newton force be placed to balance the rule? So you know the metal rule is actually a 100 centimeter structure, and this is 0 to 100 cm, and we're told that a uniform metal rule weighs. So where will the weight of this metal rule be experienced? It will be experienced at the center. So at 50 cm mark at the center, this is where the weight of this metal rule will be experienced, which is 0.5. But we're told that there's a pivot. A pivot is something like this. Is placed here, and the pivot is placed at the 30 meter mark. At the 30 meter mark. That means the distance between this pivot and where the weight of this metal rule is experienced is 20 cm. So the question is, at what point on this metal rule will this be placed for, will the 2 Newton force be placed so that this thing will be balanced? And for equilibrium to occur, the moments, clockwise moment is equal to anti-clockwise moment. Clockwise moment is the force going down this way, going to where my hand is facing this way, times perpendicular distance is equals to the force going this way times the perpendicular distance. Okay, so we have gotten all these parameters. Sometimes it's good for you to draw out what is being described in the question so that you can appreciate what is going on. So I have the clockwise moment this way. The weight of the ruler is the force that we are using as the one that is going down, multiplied by the distance between that center where the weight is experienced and the pivot, and is equals to this force is placed here. We want to know the distance between here and this place. Okay, so we'll go ahead and write it. So I can just put D here. D is the distance here. So clockwise moment is equals to anti-clockwise moment. That is for equilibrium to happen, condition for equilibrium. So clockwise is this one going through the hand of the clock like this. So the force is 0.5 times the distance is 20 cm, and for the other way I have 2 Newton force, that's times d, distance. Okay, so I can do the mass, make this obvious formula. 0.5 times 20 over 2 is equals to d. So 2 here, 1, 2 here, 10. So d is equals to 5 cm. So it's supposed to be placed at this point, 5 cm to this point, or 25 cm mark. Okay, you say where should it be placed? It depends on what is placed 5 cm to the center, but 25 cm away. This is the mark. In fact, the answer should be 25 cm. 25 cm from the center, because JAMB is very tricky. Okay, JAMB is very tricky. So normally it says where should a 2 Newton force be placed to balance the rule? It should be placed 25 cm away from the starting point. Okay, so we'll go over to the next question. Okay, so we have another question on the board. It says, this is a diagram. It says two forces, F and 250 Newton, act on a uniform body weight 50 Newton, as seen above. So the weight of this body is usually experienced at the center of the body. So that's why we put this vector coming down. Calculate, number one, the clockwise moment about the pivots. Clockwise movement is this way. That's following the hand of the clock, this way. So any force following this side this is the force, and the corresponding perpendicular distance to this pivot is the clockwise moment. So for number one, clockwise moment is 250 Newton times perpendicular distance 0.75, which is very easy. We'll get it as 187.5 meters. So that's for the clockwise moment. Now, the next question says the value of F. The value of F actually will come from the moment experienced by F, and the moment experienced by 50 will be equal to the moment experienced by this. So this first one is already the clockwise moment. So F is part of an anti-clockwise moment. F is part of an anti-clockwise moment. Okay, and we're going to sum the resultant, all the anti-clockwise moments, and equate it to the clockwise moment. Okay, let me put it on the board so I can get perspective. So for equilibrium to occur, or at equilibrium, sum of clockwise moments is equals to sum of anti-clockwise moments. Okay, now, you know, we have gotten the only force at the clockwise side is this force. But for the anti-clockwise side, I have two forces. I have this one and this one. Already, there's a distance between this place and this place. I can get the distance between here and, okay, if this whole of this is 3 meters, the center actually is 1.5 meters. So between this point and this point, I can get this point and this point by saying 1.5 minus 0.75. So 1.5 minus 0.75 will be giving me how do I get that? Let me 1.5 and 0.75, 0.75. I'm trying to get the difference. Okay, so this is 5, this is 7. Okay, 0.75. So the distance between here and here is 0.75, right? So I can get this moment, and I can also get this moment. This and this will be from here to here. Just watch what I'm doing. From here to here, okay, will be 3 minus 0.7. 3 minus 0.75. Okay, so this one is 5, and this one is 2. This one is 2. Okay, because this and this will also give me 3, right? Yes. So the distance between here and here is 2.25. So I've gotten the force on the left-hand side and their corresponding perpendicular distance to where the pivot is. You understand? I've gotten everything. For this force, the perpendicular distance is 2.25. For this force, the perpendicular distance is 0.75. So I can get the total anti-clockwise moment. I've already gotten my clockwise moment as what? As 187.5 Newton meter. I've gotten that one. But the anti-clockwise moment is the product of, sum of moments experienced by force and this distance, that is F times 2.25 and 50 force times 0.75. Okay, so I'm going to do the math from here. So this is 187.5 is equals to, this is 2.25 F plus 50 times 0.75. Let me quickly compute that. Calculator. So I have 50 times 0.75. So I'm getting 37.5. 37.5. So by the time I collect like terms. Okay, let me continue. Let me just take off this side of the board. Take off the side of the board. So I'm going to, this will come here. So 187.5 minus 37.5. 187.5 minus 37.5. That will give me 150 at this side. Then it's equals to 2.25 F. F is still what we are looking for. Okay, so 150 divided by, to get that answer, divided by 2.25. So it will give me force is equals to 66.67 newtons. So this F will be 66.67 newtons. Okay. Okay. All right, so we'll go on to the next question. Okay, so I have this question on the board. It says two parallel equal and opposite forces of magnitude 40 newton are separated by 25 cm. Calculate the moment of the couple. So the moment of the couple is given as force times the distance, perpendicular distance that between the force and where it is being applied. Okay, but note that you are going to be working with a SI unit based system. If I have 40 newton here, I should be having distance expressed in terms of meters. So I will not use 25 as it is. I'm going to convert 25 to meters, 25 divided by 100. So when I compute this matrix, I'll be getting 10 Newton meter. That is the moment of the couple. Okay, so I have a question on the board. It says three coplanar forces are in equilibrium. If two are known in this and this, 10 Newton and 17 Newton at right angle, find the third using vector resolution. So coplanar forces are forces that looks like this. This one, the first force. Second one too is at right angle. So these two of them are at right angle. So I have this one as 10, that one as 17. So for the third one to happen, it should be like this. This is, let me call it R because it's unknown. But they are in equilibrium. At this point, they are stable. Understand? So, but this, by vector, by way of vector, I can decide to transfer this by doing a broken line like this, so that the force here represents the one that is here. You understand? So this arrow is the same thing as this one. And by way of transfer too, I can do another line like this to show that this 10 is also this 10 here. So by effect, I have just gotten a rectangle triangle. This side is 17, this side is 10, and this side is what we are looking for. And we can apply Pythagoras theorem, where we say r square is equals to 17 square plus 10 square. All right? So r is equals to square root of 17 square plus 10 square. So from here on, what we have is purely mathematics. R is 19.7 Newton. So this 19.7 Newton here will be the force required to make all these things to be balanced. Okay. Okay, so this question on the board, it says a body is pulled along a horizontal surface by a rope at 30 degrees. Okay, I can put the body, let's do a diagram to represent this. So this is the body. The body is pulled along the horizontal, this is the horizontal plane. So it's pulled at this horizontal by a rope. This is the rope at 30 degrees to the vertical. Okay, so where is vertical and where is horizontal? This is horizontal, this is vertical. So it's 30 degrees to the vertical. So if I do my line like this, this is 30 degrees, but 60 degrees to the horizontal. You understand? So if the horizontal pull is 15 Newton, find the rope at find the rope tension. So this is the rope tension we're looking for. But the pull, as this thing is moving like this, that force that is moving it, the horizontal pull is 15 Newton. So again, I'm going to be doing, I'm going to be using a resolution. I'm going to resolve this along this. Okay, so to get this one, to get this one, I'll be using what is called the trigonometric ratio to resolve this. So I want to get the component of this force tension on this one. So this is actually adjacent to this, and this is hypotenuse. So I would say cos 60 is equals to adjacent all over hypotenuse. Here on what we are doing is mathematics, scale mathematics. Cos 60 is equals to adjacent adjacent is 15, and hypotenuse T is what I'm looking for. Okay? So we'll go on and say T cos 60 is equals to 15, and T is equals to 15 over cos 60. So T cos 60 is actually 0.5. So by the time you do that, T 15 over 0.5 will give us 30 Newton. So the component tension on the rope is 30 Newtons. So we've been able to just sample some questions that are coming from equilibrium of forces, calculation questions. Questions are endless. You can check our description for other questions that are also solved. Then in the comment section, you can also see some questions there. So please say to our channel, subscribe to our channels to get good videos on the stems. So I hope this video has been informative for you. I'd like to thank you for viewing.